Hey there, sports fans. Today we're going to talk about trigonometric ratios. So trigonometry is a Greek word coming from trigon, meaning triangle, and metron, meaning measure. So the study of trigonometry involves triangle measurement. A trigonometric ratio is a ratio of the lengths of two sides of a right triangle. Okay, great. What does that really mean? Basically, you use trig, especially in right triangles, if you have the angle, but you're missing a side or two. You can figure out a missing side if you know the angle. Or if you know the sides, you can figure out the angles. Okay? So if I have a side length of 15 and a side length of 17, what angle are they making? I could use trig to figure that out. So here there are 6 trig ratios: sine, cosine, tangent. Then there's 3 others: secant, cosecant, cotangent. But really, you talk more about those in pre-cal. In geometry, you just go over sine, cosine, and tangent. And that's a good starting off point anyway. Okay, so sine is defined by the opposite over the hypotenuse side. Cosine is defined by the adjacent over the hypotenuse side. And tangent is defined by the opposite over the adjacent side. Now, what do I mean by opposite, adjacent, hypotenuse side? So here we have a triangle. And the opposite, the longest side is always the hypotenuse. And the opposite side depends on what angle you're looking from, which is why this says A over C, because A, the little a, is opposite of angle A. And then you see it says sine B, and it says little b over C, because looking from the capital letter B, the little b is across from it. It's opposite of it. And this one's the hypotenuse. That's kind of what I mean. I'll talk more in detail about it later, but I wanted to just write this down. Just remember all that sine, cosine, tangent stuff. Just remember so, ka, toa. All right? So, opposite, sine, opposite over hypotenuse. Ka, cosine, adjacent over hypotenuse. Toa, tangent, opposite over adjacent. Okay? So I can read you these book definitions all day long, but let's just do some of these. The directions call for to write each ratio as a fraction and a decimal, but to save time for the purpose of the video, I'm just going to set it up as a fraction. You can always type it in the calculator later and get the decimal. Okay, so sine of P. I'm going to look at angle P. Angle P is here. What is opposite of P? 15. So I'm going to write opposite, and this is opposite of angle P. What is opposite, or what is adjacent to P? Well, adjacent is like it's next to. So you have 8 or 17. The reason why 8 is the adjacent side and not 17 is because 17 is across from the right angle. So whatever side is across from the right angle is always the hypotenuse. Okay. Now that I have my opposite, adjacent, and hypotenuse sides labeled, I can make my ratios. So sine is opposite over hypotenuse. So sine is 15 over 17. So sine of P equals 15 over 17. Cosine of P is the ka, A over H. So cosine of P is 8 over 17. And tangent of P is opposite over adjacent, the toa. So I'm going to write 15 over 8. Okay, so really what we're doing is we're plugging in an angle for P, and then it's outputting some number, and whatever the number is, it's the same number as typing in 15 over 17, or 8 over 17, or 15 over 8. Okay, that's really what the sine, cosine, tangent stuff means. Now, I'm going to look at sine Q, and cosine Q, and tangent Q. I'm going to look from angle Q is what I should have said. So here's angle Q. What is opposite of angle Q? 8. So this is opposite of Q. So that makes 15 adjacent to Q now. And the hypotenuse stays the same again because it's always a hypotenuse. So let's see how that changes our answers. Okay, so I have sine of Q. That's so opposite over hypotenuse. Opposite over hypotenuse is 15 over 17. Cosine A over H, 15 over 17. TOA, well, my opposites and my adjacents flipped, and so you'll notice that the opposite is 8 and the adjacent is 15 now. And it's the same fraction as before, but it flipped. And you'll notice that sine and cosine basically flipped with each other when I looked from a different angle. So if you'd like, go ahead and try the next one on your own. So pause it because I'm just going to keep on going. If I were to express a fraction for sine L, what's opposite of L? Because I'm going to use the opposite in hypotenuse. 12 is opposite of L, and hypotenuse is 37. So this one's OL. So this one's 12 over 37. Cosine L, that makes this one A of L. So that makes this 35 over 37. Tangent, opposite over adjacent, TOA, 12 over 37. Sine of N. So what's opposite of N? 35. So opposite of N, 35 over 37. What is adjacent to N? The 12. This is an A. 12 over 37. Tangent, opposite over adjacent now, is 35 over 12. 35 over 12. Oh, look, I wrote 12 over 37 for my other one. It should have been 12 over 35, opposite over adjacent. Yeah, I think I said 12 over 35, but I wrote down the wrong thing. But okay, let's go to the next page. Find x and near x hundredth. Now, to do this stuff, you need to make sure your calculator is in degree mode. So, from a calculator screen, you need to press the dock button. And then from there, it's dock 7, that's settings. Settings. From that, you hit 2, document settings. And once you do that, there's an option that says radians. You need to change that to degrees. So I'll put radians to degrees. Okay. Now let's set these up. Here I have 25. So 25 is looking at x, so that's the opposite. 18 is touching the 25, that's the adjacent. The reason why that's the adjacent and this side's the hypotenuse is because this side's opposite of the right angle. So I'm using the A and the O. There's nothing on the hypotenuse side. So which one uses A and O? That is TOA, tangent, T-O-A. So I'm going to write tangent of 25 equals x over 18. And to make these really easy to solve, just throw whatever your sine, cosine, tangent thing is, throw that over 1 and cross multiply and divide. So I'm going to cross multiply this and divide by 1. So that doesn't change anything. So I'm typing in 18 times tangent 25. Make sure you use parentheses. And I'll round to 2 decimal places. I'm going to get 8.39. That's what that side length was. This one. let's say 70. This is adjacent to it. This is the hypotenuse. So I'm going to use cosine. Cosine 70 equals 15 over x. Throw this over 1, cross multiply. Now it's 15 times 1 divided by cosine 70. So 15 divided by cosine 70 will give me my answer. Type that in. We're going to get 43.86. All right. Okay. Next. 15's looking at x, so that's opposite. 12 touches the 15, but it's also opposite of the right angle, so it's the hypotenuse. So that means I'm going to use sine. Sine of 15, always plug in the degree. On the other side, we were looking at letters. I was doing sine of n or sine of L. I was plugging in the angle of that, see, sine of 15 is the same thing as sine of m. See, we were just practicing setting up before. So sine of 15 equals opposite over hypotenuse, so x over 12. Throw this over 1, cross multiply, we got 12 times sine of 15 divided by 1. So 12 times sine of 15 is about 3.11. Okay, so the rest of the examples are pretty much just like this. I'm going to do these last two just because they're word problems, just for the sake of time. I'm already at 12 minutes here. I don't want to make this video a whole lot longer. So a certain part of a hiking trail slopes upward at about 5-degree angle. After traveling horizontal distance of 100 feet along the part of the trail, what would be the change in the hiker's vertical position? It's basically asking you how far did you walk since you walked up a hill. So if you were able to cut into this hill, it's 100 feet. So I'm going to look for how high the hill is. So x is opposite of where I am. And let's see here. The 100 is adjacent to where I am. So to figure out the x, I'm going to do, you guessed it, tangent. So tangent of 5 degrees equals opposite over adjacent, x over 100. Throw this over 1, cross multiply, divide by 1. 100 times tangent 5 is about 8.75. Now, I can use trig, Pythagorean theorem, or Pythagorean theorem, I should say, to figure out the y. I'm just going to keep using trig. It's actually quicker. So looking at the 5, I'm still looking from the 5. The y uses my h and my o now. No. Don't use that one. Use 100. You can get more of a precise answer. Because I used 8.75. That's a rounded number. So I'm going to use a and h. That's cosine. So I'm going to say cosine of 5 degrees equals a of 100 over h, which is y. And throw cosine over 1. That's 100 times 1 divided by cosine of 5. So 100 divided by cosine of 5 will get me an answer of about 100.38. So if you're walking up a hill that's only 5 degrees incline, what was the units? You're walking 0.38 feet more. That's like 6 inches more. Less than that, actually. So that's what that one's saying. A Finnish trainer sets the incline on a treadmill of 7 degrees. The walking surface is 5 feet long. Approximately how many inches did the trainer raise the end of the treadmill from the floor? How long is the base of the treadmill? Okay. If you were figuring out the base of the treadmill, then there should be an X right there. So 7 degrees, what's opposite of that is the y. Opposite of the right angle is the 5. So that's hypotenuse. So that makes this the adjacent side. So to figure out the y, I'm going to go use opposite and hypotenuse. So that's sine. So I'm going to go sine of 7 degrees equals y over 5. Throw this over 1, cross multiply. 5 times sine 7 divided by 1. Y equals 0.61. Looks like your trainer raised it 0.61 feet. Times that by 12, get it in inches. Let's see here. That's about 7 inches, a little more than that. Just thinking about it in my head. Now, if I were to figure out x, x I'd use AH, so I'd use cosine. I'd say cosine of 7 degrees equals x over 5. Throw this over 1. 5 times cosine of 7 divided by 1. X will equal 4.96. Alright, so that is how long the treadmill is. Almost 5 feet long, but not quite. If you have questions on these three, send me a message. I just skipped them for time. We're at 17 minutes now, so I hope this helped. Thanks. Bye.